So that's fine. Okay, so you want to look at 7 to start with. So, yeah, right away, if you look at the interval given to us from negative 3 pi over 2 to negative pi over 2, we notice that theta is going to be negative. So when we're drawing our negatives, we know that we're going clockwise. So we start at 0, and then we go clockwise to negative pi over 2, negative pi, negative 3 pi over 2. So far, so good? So the quadrants we're looking for are quadrants 2 and 3. Cool so far? Okay. All silly turtles crawl. We're going to figure out that sine is negative in quadrant 3. And again, we have a negative angle, so we're going to be going clockwise rather than counterclockwise. So that's our theta. Still doing good? If I'm going too fast or I'm doing something you're not sure about, pop in and ask, okay? That's not just Victoria, that's anybody. Lily?
No,
Why in quadrant 3?
Yeah.
So the all silly turtles crawl is just an acronym to remind us what quadrants the trig functions are positive or negative in. So the A in quadrant 1 stands for all. So all of sine, cosine, and tangent are positive in quadrant 1. The S in quadrant 2 tells us that sine is positive. So cosine and tangent are negative. The T in quadrant 3 tells us tangent is positive, but sine and cosine are negative. And the C in quadrant 4 tells us cosine is positive, but sine and tangent are negative. So if I look at our particular problem here, we have sine is negative. Well, in quadrant 2, sine has to be positive, so it has to be in quadrant 3. Is that okay?
Yeah.
Yeah, no problem. Okay. So we feel good about how I figured out what quadrant our answer is in? Okay. So our alpha then is going to be that angle there, always between the terminal, the acute angle made between the terminal side of theta and the x-axis is always the alpha. And now to determine whether we're going to be adding or subtracting alpha, I'm going to use the rules here. So if theta is positive, if the last axis we pass is vertical, we're going to be subtracting alpha. If the last axis we pass is horizontal, we're going to be adding. But if theta is negative, all that reverses. So in our situation, where theta is negative, the last axis that theta passes through is a vertical axis. So we should be adding alpha. So far, so good. The last thing we need to address is what are we adding alpha to? So alpha is here. We're always going to be adding it to the part of the x-axis that makes up alpha. So in this case, it would be negative pi. And what is alpha equal? Well, it's going to be the sine inverse of the absolute value, 0.56. Or negative 0.56, I should say. The absolute value, negative 0.56. So in my calculator, I want to check to make sure that I'm in the correct mode. This problem, or this sheet is asking for answers in radians. So I want to make sure I'm in radian mode. And then we'll do negative pi plus sine inverse. And I'm not going to do the absolute value of the negative. I'm just going to do the absolute value in my head and just make it a positive because it's way less buttons to press on my calculator. And it's really easy to do an absolute value in your head. You just get rid of the negative sign if there is one. So my answer should be negative 255. And we can check that. So to check that, if I do sine of that answer, I should get negative 0.56, which I do. And negative 255 should be in between negative 3 pi over 2 and negative pi over 2. So it is bigger than negative 3 pi over 2. And it is less than negative pi over 2. So we're sure that this is the correct answer at that point. Victoria, did that? So it's really the same process. The only thing that's going to change is you have to make sure you're drawing your angle correctly, that you're going clockwise instead of counterclockwise. And then when you're deciding whether you're adding and subtracting your alpha, that reverses, right?
The points on like the y-axis, like theta and switch, but not the ones on the x. Like 0 and negative 5.
Well, yeah, we're going around we're going around clockwise also. So 0, and then to negative pi over 2, and then to negative pi, and then to negative 3 pi over 2. So we're going clockwise around when we're labeling, not counterclockwise. Is that what you're asking?
Yeah.
Okay. Maria?
Is it do you go clockwise when it's negative?
Yes. If theta is negative, we're going clockwise. Everything is clockwise. Emilio?
What's the difference between what the equation is sine and cosine?
Nothing.
And then
The only thing that would the only difference is when you type your alpha in your calculator. You need to use the correct, but nothing changes from that.
and then would you be able to do another one?
Sure.
Find more sheet and use like
Okay. Landon, I saw your hand coming up too. Were you have a separate question or a follow-up to something we did? Okay. We'll come back to you then. I just figure I should check before we moved to something different. Okay. So you said number which one? 5? Okay. So I'm going to start kind of the same way. So I'm going to start by figuring out what quadrant my answer is in. So here I notice that theta is positive. Hi, come on in.
Oh, sorry to interrupt.
You're okay.
Thank you very much.
Yep. Becker and Maria. Mervent. Sorry, there's more than one Maria's. You're welcome. Okay, so since theta is positive, we know we're going to be going counterclockwise when we're counting around. So we start 0, and then pi over 2, pi, 3 pi over 2, back to 2 pi. So from pi to 2 pi is quadrants 3 and 4. Landon?
You know that the two zones are on the bottom because, like, wait, how do you know that?
Well, when I was counting around, I went 0, pi over 2, pi, that's going to be the start.
Oh,
and then 3 pi over 2, 2 pi, that's the end. So we started here on the horizontal, and we went around to the other side of the horizontal, so it's just visually, right? Just as we're labeling these in, it's like, oh, there's the start, oh, there's the end, color in between. Cool?
But on the previous problem, you had the zones on the left. Like,
Right, because the interval was different.
yeah, but like, how do you know what the intervals should be? Or is that just a fixed number?
This is given to you in the problem.
I'm sorry, I mean, like, how do you know what, like, you wrote pi over 2, and then at the bottom you wrote, I can't see.
3 pi over 2?
Yeah, like, are those two, like, always going to be
So how many degrees is one quadrant? 90 degrees. 90 degrees in radians is pi over 2. So every quadrant is half a pi. So again, like 0, half a pi, 1 pi, 1.5, 2, and then 2.5, 3, 3.5, 4, and you just keep counting around as far as you need to cover the interval that you're given. Is that okay?
Yeah.
So that's the increment that you're counting by. Every change is a half a unit of pi. Okay? The next thing we do is we do all silly turtles crawl to decide where or which of these quadrants tangent is negative in. Quadrant 3 or 4, which one? 4, right? The T in quadrant 3 tells us tangent is positive there. We want tangent to be negative. And since we're dealing with a positive theta, we know we're going around counterclockwise. So that's my theta. Yes, Jane.
For this problem, why would you multiply tangent theta by the inverse of tangent? Because aren't you supposed to get theta by itself?
Yeah, you can do that if you want.
Okay.
It doesn't change anything that we've done to this point,
Okay.
but it's fine.
Because I think that's what you did in that.
Yeah, that's still doing this. It's the same thing, right? Tyler?
This might be a dumb question, but
It's
how
okay.
do you know if if theta is positive or negative?
We're told right here in the interval.
Oh, so
Has to be between pi and 2 pi. Those are positive numbers. It's got to be positive. Is that okay? As opposed to the previous example that was in between 2 negative numbers, so it clearly had to be negative. Lily, did I see your hand up also? Okay. Emilio, still doing okay?
yeah.
Okay, back on track now. So my last step here, this problem's on worksheet 1, the instructions were to use the unit circle to do this. So now that we figured out where on the unit circle we're looking, we need to look in quadrant 3. What we're going to be using then is this piece. So we know that tangent on the unit circle is the y-coordinate over the x-coordinate. And that has to equal negative square root 3, right? That's what it's told us in green. Okay, there? I'm writing it as a fraction because when I go to the unit circle, I'm going to be looking for a place in quadrant 3 where the y-coordinate has a square root 3 in it. Oops. And the x-coordinate has a 1 in it. So I'm going to go over to my unit circle. I'm looking just in this quadrant 4. I want my x-coordinate to have a 1 in it, and my y-coordinate to have a square root 3 in it. So the answer I'm looking for is 5 pi over 3. And I'm done. No calculator needed on this. You could still check this the same way we checked the other one, and that'll still work, but you don't need to actually compute this value for theta. It'll be something that you just look up and read off the unit circle. Does that feel okay, Emilio?
Yeah.
Okay. Landon, you had your hand up. You're good? Gabby, were you trying to get ready to ask something?
Cosine and sine is x over y.
So cosine is just x, and sine is just y. On the unit circle, these points x, y are cosine theta, comma sine theta. So the x coordinate is cosine, the y coordinate is sine, and then tangent is y over x. So sine over cosine. Anybody else? Emilio?
Yeah, sorry. Number one on this.
So the first thing I'm going to observe is that theta is positive, right? It's in between two positive numbers. So I'm going to draw my picture. So starting 0, pi over 2, pi, 3 pi over 2. So we're talking about quadrants 2 and 3, in between pi over 2 and 3 pi over 2. Do all silly turtles crawl. I'm looking for where sine is positive. That tells me quadrant 2 is the place. So there's my theta. Notice I'm going counterclockwise because I know theta is negative. So my alpha here is this angle made between the terminal side, or the acute angle made between the terminal side of theta and the x-axis. Since the last axis that theta passes through is a vertical axis, and theta is positive, I know I'm going to be subtracting alpha. And what I'm going to be subtracting alpha from is the end of the x-axis that is part of my alpha. And my alpha is going to be sine inverse of the absolute value, 0.11. And now it's calculator time. So that's about 303 would be my answer. And if you wanted to check that, you would take the sine of your answer and make sure that gives us 0.11, which it did, right? And then you'd want to make sure it's in between pi over 2 and 3 pi over 2. So it's definitely bigger than pi over 2. And it's definitely smaller than 3 pi over 2. So you should be pretty convinced that you have the correct answer at that point.
And then, how did you get 1.11?
No. This is the absolute value of 0.11.
Oh, okay. So what's actually preventing you from doing that?
You don't know what quadrant you're in, so you don't know whether you're going to be adding or subtracting alpha, and you don't know what you'd be adding or subtracting alpha from without the picture, right? The picture is going to tell you those two parts. What are we adding or subtracting alpha from, and should we add or subtract? Is that
Yeah.
okay? You guys feel any better? Lily?
How do you know where alpha is?
So alpha is always going to be the acute angle between the terminal side of theta and the x-axis.
Okay.
Ben?
How do you know if you're adding or subtracting?
So we wrote down the rule here. So if theta is positive, and the last axis that you pass through when you're drawing your theta is a vertical, you subtract alpha. If the last axis you pass through is a horizontal, you add alpha. So in the previous example here that we just drew, our theta is positive. And the last axis we passed through was vertical. That's how we know we'd be subtracting alpha. Is that okay?
Yeah.
And then if theta was negative, that's just reversed. So if it's theta is negative, when it's vertical, we add, and horizontal, we subtract. Is that cool?
Yeah.
So just coming straight from the picture, just from what we observe in the picture.
Okay, cool.
Again, this is what tends to make this a difficult subject, is because we're doing algebraic things for geometric reasons, right? You're looking at the picture that you've drawn and like deciding whether you should be adding or subtracting and what we should be adding and subtracting, rather than just like, here's an equation, let's push some symbols around like we did in algebra last year. So it's a tad more challenging in that regard. Jane?
So then figure out what you're adding to alpha. You would just look at the x-axis where it's making.
Exactly. Yep. So like, again, if you had, so say you had something like this, we'd have theta equals 5 pi, since that's the end of the x-axis that makes up our alpha. And since we last passed through the horizontal, we'd be adding alpha. So it just purely depends on the picture, right? A well-labeled and drawn picture tells you everything you need to know to write your equation. Welcome back. Thanks. All right. Feel more ready?
Yeah.
Hopefully not less ready, right? Okay. So let's clear our stuff. Yeah, make sure you check the mode. I don't know what this last used for.
It looks like 2 pi.
It's 4. So there's 2 questions on front and 2 on the back.
These first 2 are easy.
Yep. I mean, eventually, yes.
Okay, like not today.
That's fine. Yes. One second. Pass the rest of these out. Okay. Sure. Before everybody gets started, do me a quick favor and check your calculator mode. Make sure you're in radian mode before we get going. I hate to see you get whoppers, wrong answers because you're just in the wrong mode. So there are 4 questions on this. There's 2 on the front and 2 on the back. The 2 on the front you're going to be using the unit circle for. And the 2 on the back are going to be like the worksheet 2 problems where you're just going to use your calculator.
I feel like I've made a mistake here. So when I did this, cos is positive or negative? Would it be negative because of that? Okay, so it'd be there, not there. Okay, that changes.
Good catch.
So I kind of like totally forgot. Do these define the
Positive.
areas where it's
Positive.
where that one's positive? And the rest are negative.
Correct. Oh my goodness. Thanks, Victoria. Did you feel good? Did you feel good? Okay. Right, my good man. Thank you. Thank you. Sure. Hi.
Saw Notre Dame or my Notre Dame. They marked me as tardy.
Yeah.
That was here. Oh,
Oh. Okay.
yeah.
I just must have made a mistake then. Thanks, brother.
Before this passed, I don't have to leave now, but it says you need to do initials.
Oh.
Thank you.
You're welcome. Alrighty. Has anybody still got a quiz? No. Alright. Let's get the show on the road here. Yes. Sure. Okay. So we're going to start here in section 4.2 with a pair of definitions. So we're going to define these two terms, angle of elevation and angle of depression, just with pictures. So imagine that we have like one person standing on the ground, one person standing on at some elevated position. So when we're just standing normally, we kind of look straight ahead, like our line of sight is just straight ahead. Everybody good with that? Now let's say we're the person on the ground. If we look up to the person on the ledge there, our line of sight has elevated from the horizontal to this new place, right? We call this angle, that change, the angle of elevation. I'm just going to abbreviate that AOE. Everybody okay with that? Now imagine we're the person standing on the ledge and we want to look down at the person on the ground. There we're going to be lowering our line of sight because we're angling down now. That's called an angle of depression. Everybody okay with that vocabulary? Geometrically, what can you say about the relationship between the angle of elevation, angle of depression? Those two angles should be congruent. They're the same angle measure. Does anybody remember why? Well, congruent means the same, right? So these two angles are alternate interior angles. So notice the line of sight from each person, those lines are parallel. If you have two parallel lines that are cut by a transversal, then the alternate interior angles are congruent. That was a theorem from your geometry course. Now, all that vocabulary and the actual statement of the theorem, not that important. But remembering that, like, hey, those two angles are the same measure, that would be the piece that you'd want to make sure that you remember. Everybody okay? All right. So the way we're going to be using these definitions in section 4.2 is to kind of solve some story problems. So to be like, we need this vocabulary to draw some pictures in order to solve some story problems. So let's do a couple of examples here. So it says, Christy is looking up at the Fisher Building in downtown Detroit. She's standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the building? So we'll start by kind of drawing a picture. So there's Christy. There's my Fisher Building. We're 200 feet away. My angle of elevation, we're told, is 66 degrees. And we're looking for the height of the building. So I'm just going to translate this into just a right triangle. Now, how can I assume that that's a right angle down there? So I assume there's a right angle there, right? Why was I able to do that? Emilio? Yeah, so you have a building built on a ground. Typically, it's desirable to build the building perpendicular to the ground. One notable exception. What building do we know is not perpendicular to the ground? The Leaning Tower of Pisa is one famous example of a building not perpendicular to the ground. But in general, we'd assume that any structure is going to be perpendicular to the ground, right? And we're looking for that side. So we have a right triangle where we know a side and an angle, and we're looking to solve another side. What trigonometric tool are we going to use to solve that kind of situation? Since it's a right triangle, I can just use SOHCAHTOA. So relative to the angle that I know, I have the adjacent side, and I'm looking for the opposite side. So which of the three trig functions do I want to use? Sine, cosine, or tangent? I know the adjacent. I'm looking for the opposite. I'd want to use tangent, right? So we can say that tan 66 is equal to opposite over adjacent. And now I'm going to solve this equation. So to get the x by itself, I'll multiply both sides by 200. And then it's calculator time. What important thing do I need to make sure I do to my calculator before I start punching this in? So how were the angles represented in this problem? They were represented as degrees. What mode is my calculator currently in? Radians. So I got to make sure I switch that before I start doing these kinds of problems. And just make a note of yourself right now, be prepared on the test that you'll have to be careful about switching back and forth between your calculator modes. So 200 times tan 66 gives me 449.2. Everybody okay there? Yeah, okay. Let's do another one. So this one says, Jane has climbed a tree and is looking down at her friend Mary. Jane has climbed 17 feet into the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? So let's draw our picture. So there's Mary. I should use green, huh? There's Jane. We're told she's 17 feet in the air. We want to know how far is Mary standing from the base of the tree. And then we have that the angle of depression from Jane to Mary is 49 degrees. Everybody's okay there? So the right triangle I'm going to make is basically this one. Everybody cool with that? To do that, though, I'm going to need to make that angle 49, which is okay, right? We established earlier that those are the same angle measures because they're alternate interior. So to redraw this just as a triangle. Got that. Everybody's okay? Why could I make it a right triangle? Perpendicular to the ground, yeah. Yeah, you can assume the tree is perpendicular to the ground. It's not some janky like falling over tree. Most trees are growing perpendicular to the ground. If it wasn't perpendicular, we'd state it explicitly, but that'd be beyond the scope of what we'd be doing in this class right now. Tyler.
But doesn't the angle of the tree even matter in this context? Because it just says that she's 17 feet up. Not that, like, the tree is
Yeah. I'm not sure for what it's asking. So here's where it would matter, is if that was the case. So say it's leaning backwards this way, you would be finding this distance, not the distance from to the base of the tree, which would be this distance, right? So that's where it would matter. So yeah, a little bit, but you know what I mean? But anyways, we're just assuming that it's straight up and down, which I think is fair. Because that's most of the trees that I look that way. All right. So sine, cosine, or tangent, which one would I be using in this case? Oh, come on. Okay. Relative to this angle, what is x? Opposite, adjacent, or hypotenuse? Adjacent. Relative to the 49, what's 17? Opposite, adjacent, or hypotenuse? Opposite. So I have adjacent, I have opposite. Which one do I want? Tangent. Okay. So to solve for x, I'd want to multiply both sides by x to get it out of the fraction. And then divide both sides by tan 49. Remember, tan 49 is just like some kooky decimal, right? But I don't want to write down that long kooky decimal. I'm just going to write down tan 49 until I get to my calculator and type it in. (17) divided by tan 49. So 14.8-ish. Everybody feel okay on the solving part? Really, what's the hardest piece? Getting the picture, right? If you can draw the picture and get the triangle out of it, it's usually going to be pretty easy from there. I want to point out to you one thing. The most common mistake on this problem is students putting the 49 there. Remember, the angle of depression is from the line of sight down, not from the line of sight to the vertical, right? You know what I mean? So just be careful about that. I'm going to warn you now that you're probably going to make that mistake and put the angle of depression in the wrong spot at some point. It's an easy mistake to make. That's going to be it for this section, though. So for you guys, we're going to do worksheet 3, but I don't want you to worry about 5 and 6. Hi, Ms. Garcia. Yeah, sure. Okay with that? And then on the problem set, we can do 19 to 22, and we're not going to worry about anything past that. Well, it's now in the content library, right? So I X'd them out on the content library. So should be easy to remember not to do those. So 19 to 22 is the extra homework problems. And then worksheet 3, we're not going to do 5 and 6. Landon.
Did you ever come up